Welcome to the first lesson of simplifying and verifying trig expressions. The first little bit we're going to go over some of our trig identities. We know reciprocal and quotient identities, so this warm-up that we go through should be pretty good. We're just going to be practicing our algebra skills along with our trig expressions. So let's go ahead and get started. And our first example that we have is cosine of x multiplied by cosine of x. So if I multiply a cosine by itself, I will just get a cosine squared of x. Perfect. Number two, it's cosine of x plus cosine of x. Okay, that's just 2 cosine of x. Number three, 2 sine of x multiplied by the quantity of 1 minus sine of x. Use your distributive property and multiply both of the terms by 2 sine of x, giving us 2 sine of x minus 2 sine squared of x. Awesome. And then example 4 is 3 sine of x plus 2 sine of x. Okay, cool. Just add those coefficients. 5 sine of x. And number 5, cosine of x multiplied by the quantity of sine of x minus 4. Again, that's just our distributive property. And when we multiply cosine and sine together, we just write them as cosine multiplied by sine. So it's cosine of x, sine of x, and then minus 4 cosine of x. Good job. All right, number 6, we have a fraction and its denominator is also a fraction. So a fraction divided by itself. So we are going to multiply by the reciprocal or keep, change, flip. So it's going to be the numerator sine of x multiplied by the reciprocal of the denominator, which is 1 over cosine. So its reciprocal would be cosine of x over 1. Now if you need to see the 1 underneath the sign, you can put that there as well. And then just multiply straight across numerator to numerator, denominator to denominator. So we will have sine of x, cosine of x. Great job with those. Okay, let's try a few more. Number 7, 1 divided by cosine of x divided by sine of x. So again, that's another multiply through by the reciprocal. So I'm going to keep the numerator as 1 and multiply it by the reciprocal, cosine over sine. Its reciprocal will be sine divided by cosine. 1 times anything is what you have. So that's just sine of x divided by cosine of x. Do you remember that is the quotient sine over cosine y over x? That's the exact same value as tangent. So tangent of x is the best way to simplify that example. All right, number 8, we have 1 over sine of x divided by sine of x divided by cosine of x. Okay, so again, multiply by a reciprocal. We've got that big, huge, giant fraction bar. So I'm going to keep that numerator as 1 over sine of x and multiply by the reciprocal of the denominator, which would be cosine of x over sine of x. Again, multiply straight across. 1 multiplied by cosine is cosine of x, and sine of x multiplied by itself would give us a sine squared of x. So we have cosine of x divided by sine squared. Okay, that answer is perfectly fine. I'm going to show you an extra little step that you could take with this so you can see how it can still turn into something else. So again, that numerator is cosine, and we had sine of x multiplied by itself in the denominator. So we could actually split that fraction as a cosine of x divided by a single sine of x times a 1 over sine of x. Okay, so then we can use our other identities to replace cosine of x over sine of x with cotangent of x, and 1 over sine, its reciprocal, is cosecant of x. So you've got 2 perfectly fine answers for that particular example. All right, we're plugging and chugging along. Good job, guys. Number 9, 3 over cosine of x plus sine of x over cosine of x. Remember, if we want to add 2 fractions, I have to have the same denominator. Both of these have cosine of x as its denominator, so we can just straight up add the 2 numerators together, 3 plus sine of x, and put them over cosine of x to create that one expression, that one fraction. Great job. We could have changed stuff around with that one as well. So just to give you another option, 3 over cosine would be 3 over 1 multiplied by 1 over cosine of x. And then sine of x divided by cosine of x is equivalent to tangent of x. Okay, now going back to 3 times 1 over cosine of x. Cosine of x is secant. That's its reciprocal. So I could do 3 secant of x plus tangent of x. All right. Okay, we're plugging and chugging along. Number 10, 1 over sine of x plus 1 over cosine of x. Again, I've got to have a common denominator for those two fractions to be added together, and I'm going to need both a sine of x and a cosine of x multiplied together for the common denominator. So that first fraction, 1 over sine of x, has to get multiplied by cosine of x in the numerator and denominator, giving us cosine of x over cosine of x sine of x. Now, the second fraction, plus 1 over cosine, this needs to get multiplied by sine of x in numerator and denominator, giving us sine of x over cosine of x sine of x in the denominator. Okay, now remember, the cosine and sine multiplied together in the denominator, the order doesn't matter because they're just being multiplied together. Now that we have that common denominator, check, we can just add the two numerators together. Cosine of x plus sine of x all over cosine of x multiplied by sine of x. Okay, that is one way to do this problem. Is there another? You bet it, there sure is. And I'm going to show you that real quickly. If you caught from the very beginning that 1 over sine is actually cosecant and 1 over cosine is secant, you could have made this a really, really short and sweet problem. You could have written cosecant plus secant. There you go. So that's another option for that particular example. Good job, guys. We're doing great with these. We have just a couple more for our warm-up. Number 11, sine of x over cosine of x plus sine of x. Okay, let's take the easy route this time. We've gone a little bit more difficult and kind of thinking through fractions and stuff the first few. So sine of x over cosine of x is equivalent to tangent of x. That is a quotient identity, and then plus sine of x. That answer is perfectly fine. There's nothing wrong with it. Okay, now, if we wanted to have a common denominator so we can add the two fractions together, I would write sine of x over cosine of x plus the sine in the other term that we're adding has a 1 as a denominator, and I would need that common denominator of cosine. So I would have to multiply that through in both numerator and denominator. So now I have sine of x over cosine of x plus sine of x multiplied by cosine of x all over cosine of x. Common denominator means I can combine those two numerators, sine of x plus sine of x cosine of x all over cosine of x. This answer is good, but if you catch algebra skills and you see that common factor of sine of x, then you could factor it out in the numerator. So you'd have sine of x multiplied by the quantity of 1 plus cosine of x all over cosine of x. Okay, now, could we go farther with that? Yeah, we can keep plugging and chugging along and do some stuff, but we're just going to stop at that point. I think we're getting a good feel for how all of these work. Alrighty, last one for our warm-up. Sine of x divided by 1 over cosine of x plus 1 divided by cosine of x sine of x. Okay, so we're going to take it piece by piece. I'm going to multiply through by the reciprocal for the first and second fractions and then see where that gets me. Okay, so sine divided by 1 over cosine turns into sine of x multiplied by cosine of x over 1, okay, plus 1 over cosine of x over sine of x is 1 times, excuse me, I was going to write plus, So 1 multiplied by its reciprocal, sine of x over cosine of x. Okay, right off the bat, I'm going to keep the sine and the cosine multiplied together on the left-hand side, and then plus sine over cosine is y over x. That's equivalent to tangent, so I can just write sine of x, cosine of x, plus tangent of x. That's good. Now, if we wanted to have a common denominator, so let's say that we went back to sine of x, cosine of x, and then plus sine of x over cosine of x, and we kind of followed the same pattern we did in number 11, we'd get a common denominator of cosine. So the first fraction would have to be multiplied through by cosine in the numerator and denominator, giving me sine of x cosine squared of x plus the sine of x that's in the other term all over cosine of x. And again, you could factor out that common factor. There is a sine of x that's common, and then I'd have a cosine squared of x plus 1 all over a cosine of x. There you go. So the big question that we get to after we've done some simplifying is, when do I stop? What answer do I want? And in all honesty, you just have to follow your directions. A lot of the time, the problems are going to say, put it in terms of sine or cosine. Okay, so if that were true for number 11 or 12 in this first step where we have tangent plus sine and sine cosine plus tangent, like those wouldn't be done because we would have things in terms of tangent instead of sine and cosine. So we'd have to take it a step farther. So just keep plugging and chugging along. We'll come back with the actual lesson in the next video.